Your knife is dull. It tears tomatoes instead of slicing them. It crushes onions instead of cutting clean. You reach for a sharpening stone that costs $40, or a commercial sharpener you barely know how to use. But right now, sitting in your kitchen cabinet, there's a tool that blacksmiths have trusted for over 300 years. It costs nothing. It's already in your hand every morning, and in 30 seconds, it can restore a blade edge sharper than the day you bought it. I'm talking about the bottom of a ceramic coffee mug, not the painted surface, not the glazed side. The unglazed ceramic ring on the base that touches your table. That rough, unfinished circle is an abrasive surface rated at approximately 1,000 grit. That's identical to a medium-grade sharpening stone. Watch what happens when I take this knife that won't cut paper and drag it across this mug bottom for 30 seconds. Now it shaves hair off my arm. Stay with me, because by the end of this video, you'll never buy another sharpening gadget again. Let's start with the history, because this isn't some internet hack. This is metallurgy knowledge that predates the Industrial Revolution. In the 1600s, European blacksmiths didn't carry whetstones into the field. Stones were expensive, fragile, and heavy, but every tavern, every farmhouse, every military camp had ceramic mugs and plates. Smiths discovered that the unglazed foot ring on pottery provided the exact abrasive properties needed to maintain an edge between proper grinding sessions. This wasn't their primary sharpening method. It was field maintenance. The difference between a dull blade that gets you killed and a functional edge that keeps you alive. By the 1700s, this technique had spread to butchers across England and Germany. Meat processing required knives that stayed sharp through hundreds of cuts per day. Professional butchers didn't stop work every hour to use a stone. They kept ceramic plates at their stations and touched up their blades with 10 quick strokes whenever they felt the edge degrading. This kept them working. This kept them fast. This kept them employed. Military records from the Napoleonic Wars reference soldiers using the bottoms of tin cups and ceramic bowls to maintain bayonet edges during extended campaigns. When you're 200 miles from supply lines and your blade is your survival tool, you don't wait for replacement equipment. You use whatever physics provides. Jump forward to 1863. The United States Patent Office granted patent number 38,476 to a man named William Cross for a knife sharpening device that utilized ceramic surfaces arranged in a V shape. The patent explicitly states that unglazed ceramic produces the same cutting edge as natural Arkansas stone. This wasn't folklore. This was documented industrial knowledge, but here's where it gets interesting. By 1900, the commercial sharpening industry had consolidated. Companies like Carborundum and Norton were manufacturing synthetic abrasive stones and selling them through hardware catalogs nationwide. A blacksmith sharpening a knife on a coffee mug didn't generate revenue for anyone, so the technique quietly disappeared from public knowledge. It didn't fail. It became unprofitable to teach. Now let's talk about the science, because understanding why this works will change how you think about sharpening forever. A sharp edge is nothing more than two planes of metal meeting at an acute angle. When that angle is precise and the meeting line is free of microscopic tears, the blade cuts efficiently. When the angle rounds off or the edge develops microscopic chips, the blade dulls. Sharpening is the process of removing enough metal to restore that acute angle and smooth meeting line. You accomplish this with abrasion. Something harder than the steel, grinding away the damaged material until clean geometry returns. Commercial sharpening stones are made from aluminum oxide, silicon carbide, or ceramic particles bonded into a solid block. The grit rating indicates particle size. A 1,000 grit stone has abrasive particles measuring approximately 15 microns in diameter. The unglazed ceramic on a coffee mug is made from fired clay containing silica, alumina, and other minerals. When clay is fired at temperatures between 2,000 and 2,400 degrees Fahrenheit, these minerals fuse into a hard, porous surface with natural abrasive properties. Measured under a microscope, the particle size of unglazed ceramic averages between 10 and 20 microns. That places it firmly in the medium grit category, functionally identical to a 1,000 grit sharpening stone. But there's a critical difference. A ceramic mug costs $3. A 1,000 grit sharpening stone costs $40. The mug does double duty as a drinking vessel and a sharpening tool. The stone sits in a drawer, waiting for the twice-yearly moment you remember to use it. For field sharpening, trail maintenance, and emergency edge restoration, the mug wins on every practical metric. Here's what actually happens at the microscopic level when you sharpen on ceramic. As you drag the blade across the rough surface at a consistent angle, the ceramic particles abrade the steel. They tear away tiny fragments of metal, gradually reshaping the edge geometry. Each pass removes approximately 0.005 millimeters of material from the blade surface. After 20 passes per side, you've removed enough damaged steel to expose fresh metal underneath and re-establish the cutting edge. The process is identical to using a stone. The only difference is the delivery method. One is a dedicated tool. The other is disguised as kitchenware. How many knives do you own that are sitting dull in your drawer right now? 1, 3, 5, or more. Write your answer in the comments. Let me show you the exact technique that works every single time. First, flip your ceramic mug upside down. You're looking for the unglazed ring on the bottom. Not every mug has this. Mass-produced mugs are sometimes fully glazed to reduce manufacturing steps. But traditional ceramic mugs, stoneware mugs, and most handmade pottery will have an unglazed foot ring. Run your finger across it. It should feel rough, almost like fine sandpaper. That's your sharpening surface. If your mug is fully glazed, check your dinner plates. The bottom rim where the plate sits on the table is almost always unglazed. Same principle, same abrasive properties. Now, hold your knife at a 20-degree angle to the ceramic surface. This is critical. The angle determines the edge geometry. Too steep, and you create a thick, durable edge that won't cut well. Too shallow, and you create a delicate edge that chips easily. 20 degrees is the universal compromise. It's sharp enough to slice cleanly and robust enough to handle normal kitchen tasks. If you don't have a protractor, here's the field method. Imagine the blade is the hand of a clock, pointing at 12. Tilt it toward 2 o'clock. That's approximately 20 degrees. Place the heel of the blade against the ceramic ring and draw the knife toward you in a smooth, controlled arc. You want to cover the entire length of the blade in one stroke, ending with the tip, leaving the ceramic surface. Apply moderate pressure, not enough to scratch the mug, but enough to feel resistance. You should hear a faint scraping sound. That's steel meeting ceramic. That's abrasion happening. Do this 10 times on one side, then flip the knife and repeat 10 times on the other side. Consistency is everything. Same angle, same pressure, same motion. After 20 total strokes, test the edge. The paper test is definitive. Hold a sheet of standard printer paper vertically and slice downward. A properly sharpened knife will cut cleanly without tearing the fibers. If the knife tears or folds the paper, do another 10 strokes per side. Most kitchen knives will achieve shaving sharpness after 30 total strokes. Field knives with thicker blade geometry might need 50. But you'll feel the difference immediately. Here's the mistake everyone makes when they first try this. They use inconsistent angles. They sharpen 10 strokes at 18 degrees, then 10 strokes at 25 degrees, then 10 more at 15. This doesn't sharpen the blade. It rounds the edge into uselessness. You're removing metal in multiple directions, creating a convex surface instead of a clean V. The result is a knife that feels sharper for 30 seconds and then dulls immediately. Lock your wrist. Keep the blade at the same angle for every single stroke. Your arm moves, your wrist doesn't. This is the difference between technique and random scraping. Blacksmiths understood this instinctively, because they worked metal every day. Modern people have to learn it deliberately. The second mistake is using too much pressure. You're not trying to grind the blade down to nothing. You're removing microscopic amounts of damaged steel. Aggressive pressure heats the edge through friction, potentially changing the steel's temper and making it softer. Light, consistent pressure is faster and more effective. Let the abrasive do the work. Your job is to guide the blade, not force it. The third mistake is forgetting to alternate sides. If you sharpen only one side of the blade, you create an asymmetric edge. The knife will pull to one side when cutting, making straight slices impossible. Professional Japanese knives are sometimes deliberately ground with asymmetric edges for specific cutting tasks, but that's advanced geometry requiring precise control. For general use, you want a symmetric V. 10 strokes on the left, 10 strokes on the right. Balance. Now let's address the obvious question. Does this damage the mug? Technically, yes. You're abrading the ceramic surface just as it's abrading the steel. After 100 sharpening sessions, you'll notice visible scratches in the foot ring. After 500 sessions, you might wear a groove, but that's 500 sharpenings. If you sharpen a knife once a week, that mug will last you 10 years before the damage affects its function as a drinking vessel. And when it finally wears out, you replace a $3 mug. You don't replace a $40 stone that you would have already worn down to uselessness in the same time frame. The economics are absurdly favorable. If this technique is saving you money and sharpening your knives, hit that subscribe button and drop a like. You're learning skills the industry buried for profit. But here's where this gets truly powerful. You're not limited to coffee mugs. Any unglazed ceramic surface works on the same principle. Terracotta plant pots have rough, porous bases perfect for sharpening. Ceramic roof tiles, common in Mediterranean and Spanish colonial architecture, are traditional sharpening surfaces for farming communities. I've watched shepherds in rural Greece maintain skinning knives using broken pottery shards picked up from ancient ruins. Those pieces are 2,000 years old and still functional as abrasive tools. The ceramic toilets in your bathroom have unglazed sections on the base. I'm not suggesting you sharpen your kitchen knives in the bathroom, but in a survival situation, you use what's available. The tank lid on most toilets is unglazed on the bottom. That's a sharpening stone the size of a cutting board. Concrete blocks have similar abrasive properties. The rough surface is made from cement, mixed with sand and aggregate. It's coarser than ceramic, probably equivalent to 400 grit, but it works for aggressive reshaping of badly damaged blades. Here's a technique used by cowboys and ranch hands across the American West. Take 2 smooth river stones and rub them together underwater for 60 seconds. This knocks off the outer weathered layer and exposes fresh mineral surfaces. Those stones become impromptu sharpening tools with grit ratings between 800 and 1200, depending on the stone type. Sandstone works best. Granite works. Even limestone provides some abrasive action. This is how humans maintained edges for 10,000 years before commercial sharpening stones existed. We used the rocks under our feet. The mug technique is just the domesticated version of that ancient knowledge. But let's talk about limitations, because I'm not going to pretend this is a magic solution for every scenario. Ceramic sharpening will not fix a blade with major damage. If your knife has a chip in the edge, a rolled section, or serious pitting, you need aggressive material removal. That requires a coarse stone in the 200 to 400 grit range. Ceramic sits at 1,000 grit. It's for maintenance and touch-ups, not restoration. Similarly, if you're sharpening a blade made from super hard steel like S30V, S90V, or any of the modern powder metallurgy alloys, ceramic might not be hard enough to abrade the metal efficiently. These steels are specifically designed to resist wear and corrosion. That same property makes them difficult to sharpen without diamond abrasives. For 95% of kitchen knives, pocket knives, and outdoor blades, ceramic works perfectly. But if you're carrying a $300 custom knife made from exotic steel, invest in proper sharpening equipment. That said, even high-end blades benefit from ceramic touch-ups between professional sharpenings. A few strokes on a mug can extend the time between full sharpening sessions from 2 weeks to 2 months. You're not replacing the stone. You're reducing how often you need it. Now, let's get into advanced applications, because once you understand the principle, you can adapt it to any situation. Serrated blades are notoriously difficult to sharpen because the teeth have curved sections that standard flat stones can't reach. But a ceramic mug has a rounded edge where the foot ring meets the base. That curve fits into the serrations. Hold the knife at a 20-degree angle and use small circular motions, working each serration individually. It's slower than sharpening a straight edge, but it works. I've restored serrated steak knives, bread knives, and even rescue tool blades using this method. The key is patience and consistency. Scissors are another problem tool. Most people throw away dull scissors because sharpening them seems impossible. But scissors are just two blades meeting at a pivot point. Open the scissors fully. Sharpen each blade individually using the same technique as a knife. 10 strokes per side on each blade. Close the scissors and test on paper. You'll be shocked how well they cut. I've brought back scissors that were headed for the trash and made them functional enough to cut fabric again. Axes and hatchets can be field sharpened using larger ceramic surfaces. A ceramic dinner plate, approximately 10 inches in diameter, provides enough surface area to sharpen an axe blade in broad strokes. The technique is the same. Maintain your angle, use consistent pressure, and alternate sides. Lawnmower blades, garden shears, and woodworking chisels all respond to ceramic sharpening. The only limitation is the size of your ceramic surface relative to the blade. Here's a historical technique that deserves resurrection. Medieval soldiers carried ceramic sharpening rods. These were cylindrical pieces of fired clay about the size of a pencil. They hung from belts alongside swords and daggers. When a blade dulled during combat, the soldier didn't retreat to find a stone. He pulled the ceramic rod and made a few quick strokes right there on the battlefield. You can replicate this by breaking a ceramic plant pot into strips and smoothing the edges. Carry one in your pack. It weighs 2 ounces and sharpens any blade you encounter. But the real genius of this technique is psychological. When sharpening becomes easy, you do it more often. Most people avoid sharpening because it feels like a complicated ritual requiring special equipment and expertise. So knives sit dull for months. Performance degrades. Tasks become frustrating. Eventually, people buy new knives instead of maintaining the ones they own. The knife industry loves this cycle. They sell you products designed to dull quickly, and then they sell you replacements. A knife, properly maintained, should last decades. Carbon steel blades from the 1940s are still in service today because their owners understood maintenance. Modern stainless blades are abandoned after 2 years because maintenance knowledge has been deliberately obscured. When you realize you can restore an edge in 30 seconds using a coffee mug, sharpening stops being a chore. It becomes automatic. Your knife dulls while preparing dinner. You flip a mug, make 20 strokes, and you're back to work. Total time lost, 45 seconds. This is how professionals operate. Chefs don't let their knives sit dull. They touch up edges constantly throughout service. A few strokes on a honing rod between tasks. A quick pass on a stone at the end of the night. The blade never gets dull enough to require serious intervention. Now let's talk about something the sharpening industry desperately doesn't want you to understand. Sharpness is temporary. Every cut you make degrades the edge microscopically. A knife used to slice vegetables will dull within 200 cuts. That's one meal prep session. A knife used to break down cardboard boxes will dull within 50 cuts. Physics doesn't care about marketing claims. Steel meeting resistance equals abrasion equals dullness. The only question is how quickly you restore the edge. Commercial sharpeners want you to believe sharpening is a specialized skill requiring their products. They sell electric sharpeners for $100 that use motorized ceramic wheels. You're paying for convenience and branding. The ceramic doing the actual work costs $3. They sell sharpening systems with angle guides, clamps, and multiple stone grits for $200. You're paying for complexity that makes you dependent on their ecosystem. But a blacksmith in 1650 didn't have angle guides. He had a mug and functional understanding of geometry. He could sharpen a blade in a forest, a battlefield, or a customer's kitchen using whatever ceramic surface was available. That's knowledge the industry can't monetize. That's freedom they can't sell back to you. Here's the test that proves everything. Take the dullest knife in your kitchen right now. The one you've been meaning to replace. The one that won't cut a tomato without crushing it. Flip over a ceramic mug. Make 20 strokes per side at a 20-degree angle. Then, try cutting that tomato again. If the knife doesn't perform dramatically better, I'll be shocked. This isn't theory. This is physics that's been tested across 3 centuries by people whose lives depended on sharp blades. Butchers who lost income with dull knives. Soldiers who lost battles with dull weapons. Blacksmiths whose reputations rested on their ability to maintain edges in any condition. They proved this works. We just forgot, because forgetting was profitable for someone else. Let me give you the complete protocol that combines everything into one system. Keep a designated sharpening mug in your kitchen. Mark it with tape if you want to avoid confusion. Once a week, sharpen every knife you own. This takes 10 minutes total. Your knives will never get dull enough to frustrate you. Once a month, do a paper cutting test on each blade. If any knife fails, give it an extra 20 strokes. Once a year, inspect for major damage. If you find chips or rolls, use a proper coarse stone to fix them. Then return to weekly mug maintenance. This system costs $3 for the mug and 10 minutes per week of your time. Compare that to replacing knives every 2 years at $30 each, or paying a professional sharpening service $15 per blade. The economics are insulting. You're being charged for knowledge that should be free. Here's the final piece that ties everything together. Teach this to someone else. Show a friend, a family member, a neighbor. Break the cycle of planned obsolescence that keeps people buying solutions to problems they could solve with objects they already own. The knife industry generates $14 billion annually in the United States alone. A significant portion of that revenue comes from replacement sales. Knives marketed as upgrades when the old knife just needed 30 seconds of maintenance. Every person who learns to sharpen with a mug is a customer the industry loses. They can't patent ceramic. They can't create subscription models around coffee mugs. They can't build brand loyalty to a technique anyone can learn in 5 minutes. This is decentralized knowledge. This is independence. This is exactly what corporations spent a century trying to erase. When you sharpen your knife tonight, understand that you're not just maintaining a tool. You're participating in a tradition that stretches back before countries existed, before corporations formed, before planned obsolescence became a business model. You're using the same physics that kept blacksmiths employed, soldiers alive, and butchers productive. The mug in your hand is older than the knife industry trying to sell you solutions. Trust the mug. So here's my question again. How many dull knives are sitting in your drawer right now? 1, 3, 5, or more? Write your answer in the comments. And if this technique just saved you from buying a new knife or a sharpening system you didn't need, subscribe to this channel and share this video. Every share is a crack in the wall they built around knowledge that was never theirs to lock away. The next video drops soon. What's inside will make you question every tool you've ever purchased. Stay sharp, stay independent, and thanks for watching.